All right, so this is the fourth out of the 4 words that I said you're going to have to know. Remember what I said was going to be the first 4 questions on the quiz? It's going to be these 4 words right here, okay? And the first 4 questions on the test. I'm telling you right now. Everybody hear me? I'm telling you right now. I've told you the last several days that we've gone over this. The first 4 questions on the quiz that you're going to take on when? When's the quiz? Friday, right. Quiz is on Friday. The first 4 questions are going to be these 4 words, okay? So let's review. I'm not going to get into great detail, but let's review what we've learned so far with those 4 words, okay? At least this part of it. There's a little bit more to these about what's special about each of these points. I'm not going to talk about that in this little review. I'll talk about it some other time. So, if I tell you, let's make that look a little nicer. There we go. If I tell you perpendicular bisector, I'm going to go in order so that you can kind of remember. What word, I'll put a little arrow, what word goes with perpendicular bisector? So if I draw the perpendicular bisectors of all 3 sides of a triangle, they meet at a point of concurrency. What do we call that point? Circumcenter. Very good. That's the first one. Circumcenter. You have to know that. All right? So this is what I'm going to give you. I'm going to give you, and I'm going to put it in a sentence. All right? The sentence is a little bit wordy. But when I ask for perpendicular bisectors of a triangle, it meets at a point, right? A point of concurrency. You're going to see that word in the quiz and in the test. Point of concurrency. And you have to tell me what? That word right there. So I tell you perpendicular bisector, you tell me what? Circumcenter. Everybody got that? What was the second one that we did? Altitudes. Good. I'm not even going to talk about what the altitudes are. We've spent enough time talking about that. This is just a little brief review. So when I tell you, if you draw the altitudes of the 3 sides of a triangle, all right, what they meet at a point, all right, point of concurrency, what is the name of that point? That's the orthocenter. All right, so that was the first thing that we did. That was section 5.1. Then in section 5.2, we had 2 other words. We've only done 1 so far. We're going to do the 4th one today. All right, so what was that? Angle bisector. And I'll tell you that, okay? Oops. I will tell you angle bisector. What are you going to tell me? You're going to tell me, right, if I bisect all 3 angles of a triangle, they meet at a point of concurrency. All right, and what is that point called? It's called the incenter. All right, so far that's our review. All right, so that's just review. And you got to know those. Now you got to know a little bit more. All right, the circumcenter is equidistant from the 3 vertices. Okay, that's special about the circumcenter. The orthocenter, what's special about the orthocenter? What's special about the orthocenter? Nah, come on, I've said this a bunch of times. There's nothing special about the orthocenter, okay? There's nothing special. It's not equidistant from anything, all right? So there's nothing special about the orthocenter. Tell you what, I wasn't going to do this, but I'm going to do it anyway. Circumcenter, what's special about it? It's equidistant from the what? From, or to, I guess you could say, to, or from the, what? Vertices. Remember that? Okay. So it's equidistant from the vertices. All right, which means that point, that circumcenter, if I draw a line to one vertex, then to another vertex, then to another vertex, what's true about all 3 of those lines? They are equal. Okay, there's nothing special. Nothing special. I'll write it down. Maybe you'll remember it that way if you see it. All right, so there's nothing special about the orthocenter. They do meet at one point. Okay, so that's good. Two guys over there, are you going to pay attention at all? Drew, Ben? You're not even looking up here. I mean, it's bad enough you're talking to each other, but you're not even looking up here. Okay, I'm going to shut up because I'm just going to keep going. All right, what's special about the in-center? We talked about this yesterday. It's also equidistant. But what's it equidistant to? Equidistant means the same length. Okay, they're equal in distance. That's what that word equidistant means. The same length to the what? Or from, I think the book says from. Not from the vertices, that's the circumcenter. It's from it's from the sides of the triangle. And what is the distance from a point to a side? It's the what? It's the perpendicular distance. Okay, so it's equidistant from the sides of the triangle. All right, that's angle bisector. So today we're going to do another one. Let's just add it to the list. And we'll talk about it after I add it to the list. Okay, this one is called the median. I think we mentioned it very briefly at the very end of yesterday. Okay, it's the median. We'll talk about what that is here in a second. All right. So you should, it's on the screen, you should be able to know what point is formed. If I draw the medians, and again, you may not even know what the median is. We're going to talk about that here in a minute. But if I draw the three medians on a triangle, they're all going to intersect at one point. There's a point of concurrency. All right. What do we call that point of concurrency? That's right. That's the new one. That's called the centroid. And there's something special about it. I'm not going to deal with it just right now. All right, so I'm not even going to put anything in parentheses after that. But there's your four things. I'm telling you right now, these are the first four questions on the quiz, and they're also, excuse me, the first four questions on the test, okay, whenever we finish this chapter. And we've just started the chapter, so it's going to be a while before we take the test. But we are taking a quiz on Friday. All right, so these four things right here, I don't know what else I can say. Okay, you have to study them. You have to know them. You have to know that perpendicular bisector goes with circumcenter. So what are you filling in? What are you actually writing in when I give this question on the quiz? I'm telling you perpendicular bisector. What are you telling me? Circumcenter. So that would be one of your answers. I don't give you a word bank. I don't give you choices. You have to know that word off the top of your head. Everybody got it? I mean, I'm giving it to you right now. Here's your word bank, all right? So you just have to remember what it is. If I give you altitude, what word are you giving me? Orthocenter. If I give you angle bisector, you're telling me incenter. And if I give you median, you're telling me centroid, okay? Those four words in red right there are the words that you have to know, that you have to write down on the quiz and on the test. Can I be any more clear? I don't think so, okay? I'm like handing it to you. It's like I'm just giving you the answers to the first four questions on the quiz and the first four questions on the test. All right? Isn't that nice? Okay. You're welcome. All right. So now, let's talk about that fourth one. Okay? What in the world is a centroid? Well, first of all, before we talk about centroid, what word do you think we're going to have to talk about? Come on. It's right there. Median. It's right there, okay? I'm trying to make this as easy as I can for you. You just got to take a hold of it. All right, so before we talk about centroid, we got to talk about what the median is. All right, well, let's talk about that. And I'm just going to do this with a triangle. All right, so again, I'm just going to, seems like every time the triangle looks the same, but that's okay. I'll just make it look like this, make it as simple as I can. All right, there's going to be some similarities to this median and some things that we've done before. All right, so here's what a median is. Let's call this ABC. All right, and I'm going to do this in red. We've kind of been like color coordinated through this whole entire thing. If you look at this, every time I draw one of these, like the perpendicular bisector, the altitude, the angle bisector, this median that we're going to do right here, it's always been in red. All right, and then the thing that's special about that point where they intersect each other, that's always been in yellow. So we're going to kind of do the same thing here. So what I'm going to do, actually, I've got to find the midpoint first. What I'm going to do is I'm going to find the midpoint of all three sides. All right? So let's just find the midpoint of AC. See that little blue dot right there when I highlight it? That would be where the midpoint is. So right there, that's that midpoint. So let's just draw one median, and then in a second we'll draw all three of them. So what a median is this. Remember, it's not a perpendicular bisector because we've already found the midpoint of three sides, haven't we? But what did we do before? We went perpendicular to that midpoint, didn't we? That was the very first one that we did. That's not what a median is. It does go to the midpoint, but it's not perpendicular to that side. It's from a vertex to the midpoint. It's as easy as that. Everybody see that? I'm going from a vertex to a midpoint. Okay, that right there is a median. We'll put some points in here later in a second. Let's just write the word. Median. Okay, it's in red. I'll write this word in red. So what is the median? It goes from where? Where does it start? Well, no. Well, you could start it here, but where's this starting? Where's my pen? At a vertex, right? And it goes to the midpoint. Everybody got it? So if that's the midpoint, that and that would equal each other. So that's a median. So guess what we're going to do? We've done this. This is like the fourth time now we've done this. We're going to draw how many medians? 3 of them. That's right. So let's go from A. Well, first of all, I got to find out where the midpoint is, don't I? So the midpoint is right there. If you're drawing it yourself, you just have to eyeball it. Hopefully it works. And I'll tell you what, while we're at it, let's find the midpoint of this one. Looks like it's about right there. All right, so there's my midpoints. And now what am I going to do? I'm going to draw a line segment from where? From a vertex to the what? To the midpoint. Good. Okay, from that vertex to that midpoint. What do you think all 3 of these lines are going to do? They're all going to meet, aren't they? They're all going to meet, and what is that point, Zion? That's the centroid, right. So if I start here and I go to the midpoint, hopefully, yep, look at that, it's perfect. And check it out. So all 3 of these are medians, right? Because that's the midpoint, right? See that midpoint? Those 2 things are equal. If that's the midpoint, these 2 things are equal. These 2 segments. And look what happens. They all intersect. What's the word we've been using this whole time? The lines are what? Starts with a C. Not congruent. Concurrent. Right. It's pointed concurrency. Right. What does pointed concurrency mean? It just means that all 3 lines just intersect at the same point. That's all it means. You with me? We have a name for that pointed concurrency. All right, you've said it a couple times. It was titled this lesson. What is that point called? It's called the centroid. Everybody with me? So now, when you go back up here, that should make some sense, correct? So when I draw all 3 medians, what do I get? I get a centroid. So that point right there is considered to be a centroid. Yes, sir. Right now, got important stuff coming up. All right. Now, there is something special about that centroid. Now, this is a little different than what we've done in the past. What's been true? What's been special about these other ones? Let me sign this, and then there we go. All right. So what was special about the circumcenter? Well, it was the same distance to all 3 vertices. What was special about the orthocenter? Nothing. Nothing was special about it. What was special about the incenter? It was equidistant from all 3 sides. What's special about the centroid? Well, I'm glad you asked. It's not exactly the same as what we've done before. I'll tell you what, let's get rid of that. So let me show you this. I'm not even going to ask you, I'm just going to show it to you. Let's do, let's make this white. We'll call this X, Y, and Z. And I'll call this M since we did the median. Or you could, I don't want to call it C because I've already called it C. We'll just call it M right there. Okay, everybody with me so far? So watch. This is pretty interesting. At least for me. Maybe not for you. But I think it's kind of interesting. That watch. Do you see this little part MY? And do you see this part MB? There is a relationship between those two segments. Now, do you think they're equal to each other? Like MY? No, that looks a lot smaller than an MB, doesn't it? All right. So this MY, I'll tell you what, let's just put a number in here. Let's say that was 5. I'm just making that up off the top of my head, okay? So MY or YM is 5. Take a wild guess what you think MB is going to be. It's going to be 10. It's going to be exactly twice as big. You see that? So the part that goes from the vertex to the centroid is twice as big as when you go from the centroid to the midpoint. Do you hear me on that? So this little bit right here that goes from the centroid to the midpoint, this goes from the vertex to the centroid. This is going to be exactly twice as big as this. Or you could say that this is half of this. That's right. Okay, good point, because that's kind of the stuff they're going to ask. So they might ask, watch this, they might just give you one thing, okay? They'll tell you that this is the centroid right here, okay? So they might not even tell you it's the centroid, but how do you know that's the centroid? Because this hits the midpoint, this hits the midpoint, and this hits the midpoint. So automatically, what is that point? M. It's the centroid, okay? So if that's the centroid, and if I told you that MB was 10, and I asked you for BY or YB, how would you find that? Well, you would divide this by 2 not to find YB. You'd divide this by 2 to find what? MY, all right? And now, if I asked to find BY, what would you do? Just add them up. Okay, so what is BY? It's 15. Does that make sense? Yes. Yeah, absolutely. This is homework, this is quiz, this is test, stuff like this, all right? So that's what's special about this, all right? What's special about the centroid? Well, the one segment is twice as big as the other segment. Or, let's say it like this. The longer segment is twice as big as the shorter segment. Or I could say, give me a sec. Or I could say the shorter segment is what? How much of the longer segment? It's double. Well, no. The short is half of the longer one. You with me? Sincere question? Can't hear you. For ZA, yeah, but they would be different numbers, okay? Like, just because this is 5 does not mean this is 5. All right, let's just make something up. I'm just making this up off the top of my head. Does that look a little shorter? So let's call this 4. Okay, and what if I asked you to solve for a Z? Okay, so I told you MZ was 4. What is AZ? How'd you get 12? Okay, so if you double 4, you get what? 8. And now what do? Add them up and you get what? 12. Or, watch this. Do you see a little pattern going on? If I know the short one, how do I find the whole entire median? Multiply it by 3, that's right. Do you see it? Okay. Look, multiply this by what? By 3 to get what? The whole entire, right, 12, but to get the whole entire median. Make sense? All right, so let's say this was, again, I'm just making this up. Let's say that was 6. What's the whole thing, XC? It's 24. So you could, no, it's not 24. It's 18, right. So if I know the shorter one, watch, I could find the longer one by doubling it, correct? Or I could find the whole thing by tripling it, right, multiplying it by 3. Either way will still work. Does it work? Let's find MC. What's MC? It's 12. And then if you wanted to go that way, you can. Okay, if you forget about multiplying by 3, if that bothers you, you could always find the longer one. Just double it. That's 12. And what's XC, 6 and 12, is 18. You get it? Now, the theorem, they talk about 2/3. They say that the shorter one from here to the midpoint is 2/3 of the whole thing. All right? I think sometimes that confuses people. All right, so a lot of times I don't even mention it. Thought I'd just mention it to you guys. All right, so don't worry about the 2/3. Actually, I'm sorry. This would be 1/3. This would be 2/3. So from the vertex to the median would be 2/3. This would be 1/3. Do you agree that that's true? Okay, 1/3, 2/3. But I don't like to think of it like that. I just like to think of it like we talked about. The shorter one is half of the longer one. Or you could say the longer one is what of the shorter one? Twice as big as the short one, right? Okay. Or I could say the whole median is how much of the shorter one? Everybody listen, come on. The whole median is 3 times the shorter one. You with me? So I could give you any combination of these, right? I could just give you the short one, right? So again, we'll use, let's just use a different number. Let's say that was 3. If I gave you the short one, what's the long one? 6, okay? What's the whole thing? It's 9. 3 times 3, right? Here's the one that's probably the hardest one that I could give you. Let's get rid of this. What if I told you that AZ, let's just do this one right here. We've already used these numbers. Let's just do it again. What if I told you that AZ was 12? All right, so this whole thing was 12. Everybody see that? What if I asked you to find AM and I asked you to find MZ? What would you do, Abdul? Okay. Sure about that? Remember, AZ is the whole thing. It's not just AM. That's it. That's the key. Everybody watching? Okay. Because remember, if we knew the short one, how'd you get the whole thing? You multiplied it by 3. But what if we know the whole thing? And then you just divide it by 3. Remember, this is 1/3. The shorter one is 1/3. The longer one is 2/3. Okay. So this is 1/3, or divided by 3. What's 12 divided by 3? It's 4. And now this one, AM, should be easy. So if you know the short one, you should know the longer one. So what's AM? It's 8. You see that? All right. So AM would be 8 and MZ would be 4. Okay. If I gave you, right? So if this was given to you right here, if I told you that was 12, then find the shorter one first. How do you find the shorter one? Divide it by 3. See? 12 divided by 3 is 4. So that's 4. This is double that. It's 8, and you're good to go. Make sense? So this one was a little trickier than the other ones. It wasn't just like these medians are not equal to each other. This little segment and this segment right here are not equal to each other. So there's nothing that's equidistant, is there? All right, so we can't say equidistant. So we do know that the shorter one, and how do I know which one's the shorter one? Do I just look at it? No, it's from the centroid to the what? To the midpoint, right? That's the shorter one. Okay, everybody see that? That's the shorter one. What do I call this one? The longer one. I'll just go short and long. Is that all right? So I got the shorter one. I got the longer one. The longer one is twice as big as the shorter one. The whole thing, what's the whole thing? It's 3 times the shorter one. So it's a couple things, 2 or 3 things that you got to remember about this. But it's kind of cool that it works out like that. It's not like people just came up with this. All right? I mean, this works with any triangle. If I take a triangle and I go from one vertex to the midpoint of another vertex, I hate to say it just happens. If I spoke in a public school, I would probably say, yeah, it's pretty interesting that this just happens in nature. Okay, but I don't teach in a public school. I teach in a Christian school. So who do you think designed this? Was it some old geometry guy from way back? Like Mr. Euclid, was he the one that designed this? Nah, he didn't design it. It didn't just happen. It's not just in nature. Talk to me, Christian school kids. That's right. God designed this thing, all right? And you may think, well, God's got a lot more important things to worry about than figuring out what a centroid is. He didn't come up with those words, but this is something that actually happens, and I think it's by design, all right? And I think God designed a lot of this stuff. A lot of this stuff what we do in geometry, we're just discovering. We're not like coming up with it. You know what I mean? Like, even like Pythagorean theorem. I saw somebody making fun of Pythagorean theorem on some YouTube video and saying, I think it was on Facebook or something like that, and they're like, I don't know, they started talking about, yeah, in school, we learn stuff like this, and the girl on there was kind of putting down learning this. Did you learn this in Algebra 1? Pythagorean theorem? All right. So, and she did this. She scribbled it out. She says, that's not what it's important. And then she starts talking about this crazy thing about positive and negative energy. And this is what we need to learn in school about how to get along with each other and all this kind of stuff, you know, just gobbledygook stuff. But she just kind of blew off a very, very important mathematical concept. Without this concept right here, okay, you wouldn't be able to stand in buildings. You wouldn't be able to have structures where you've got right angles. I mean, you don't know how important this is. Now, maybe not in your everyday life. Guys, listen, still talking. Just because I go off on a little tangent here doesn't mean you quit listening. You don't understand how important this is. This is super important in our livelihood. We use it every single day. Okay, does that mean that we actually do the math every single day? No, of course not. But people have done it to make this building. Okay, they couldn't have made this building without these basic principles. All right? You couldn't. No matter where you go, this is everywhere. And for people to put it down and say, why are we learning this in high school? This is stupid to learn. We should just learn that. I hear people say this all the time. Why do we learn this high-level math in high school? We never use it. You know, I've had parents come up to me and say, did I ever tell you this story? This is at my other school. This girl said, I'm not doing homework anymore. I'm like, why not? She says, my mom said I didn't have to do it. I'm like, oh yeah? Why'd your mom say you didn't have to do it? She says, well, I never use this stuff. I've never used this stuff in my life. You'll never use it in your life. And so you don't have to do the homework. You don't have to be in there. I'm like, well, first of all, you do have to do the homework because I'm going to give you a 0 every time you don't do it. So that's one reason you should be doing it. Okay, but for a parent to tell their kid, I've never used this, so you don't have to learn it, that's insane to me. That's crazy because you never know who's going to use this stuff. I've had tons of kids go off and go to college, become engineers. I've had kids that I've taught that became doctors and nurses and all kinds of things where you had to know a lot of this math. Does everybody use it every day? Of course not. All right? Nobody's ever said that. And we shouldn't think of that. We shouldn't think of education as something that you only learn just because you're going to use it one day. Where you use it is in your mind, in your brain, okay? You think, you discover things, you solve problems, you become a problem solver. Tell me something in life where you don't have to be a problem solver. Even on the sports field, even in the football field, you got to figure out, you got to be a problem solver. You're like, this guy's getting through our line. We got to figure out something to do to stop this guy, all right? There's always times in life, no matter what you do, no matter how important or not important you think your job is, you're going to have to be a problem solver. And that's what I'm trying to teach you. Are you always going to be a geometry problem solver? No. Okay, but what this does, it gets you thinking. It gets your mind thinking about solving problems. That's what this class does. All right, so for a parent to say, you know, I never use this, so you're never going to have to use this. To me, that's just crazy and it's insane. I don't think I ever did talk to the parent about it. I probably should have. That was in my early days of teaching. I couldn't believe that a kid said that they weren't going to do homework anymore. because their mom said they didn't have to. It's nuts. But anyway, how'd we get talking about that? I have no idea. Kind of got a little excited about that, didn't I? How did I start that? Did she? No, I think she continued doing it because I told her I was going to give zeros every time. You know, oh, okay, I don't want to get a bad grade, kind of thing. But I don't know. It's just nuts. So there are reasons to learn this stuff. Are you going to do this every day of your life? Of course you're not. Oh, I know what it was. Started talking about this thing and that Facebook video that I saw. Just kind of made me mad. And when I read a bunch of comments on that video. You need to see a doctor. Really do. Got an issue. So when I see these, I read all the comments, and a lot of the comments were kind of backing up the way that I thought. They're like, I don't know. I should have saved the video so I could show it to you because I don't know. This girl, she drew like a picture of a person, better than that, I'm sure, and she started talking about the good vibes or the positive energy. So she was going, oh, there's positive energies right here, and then there's negative energies right here. And she says and one thing she said was scientifically wrong. You guys take science class? What do you guys take? Oh, you're biology. You took physical science last year, right? Did you take physical science? What do you know about positive and negatives? Well, if I put two positives together, what do? Do they attract? Do they? No, they repel each other. So this girl on this video was putting this down, right? She was putting down learning stuff like this in high school, but then she's like, oh, the positive energies attract each other. They don't. In chemistry and physics, the positives don't attract each other. All right? She's saying, so we have to be more positive. That means if we send out good positive vibes, then we're going to get good positive vibes back. Well, actually, and she was trying to use science, I'll put that in quotes, use science to prove what she was saying was right. And then so many people on the comments were saying, well, if she knew anything about science, she would know that two positives don't attract each other, okay? They repel each other, all right? So anyway, just thought I'd throw that out there. You guys are a captive audience, so you have to listen to what I say. So there you go. All right, so now we are going to 23 to 37. Does that look right? Let me look at the homework. For some reason, I think... Actually, let's add a few more on there. Yep. Let's add 8 to 12. We got to do that. So I'm going to put that on my list so I don't forget next time. All right, here we go. Here's your homework. It's a little different than what I put on RenWeb. All right, so it's section 52B. It's page 218. It's actually probably 217 and 218. So pages 217 to 18. And I'm going to throw 8 to 12 in there. They should be really quick and easy. Okay, there's really not much to do there. You just kind of look at it, just answer some questions. And then you're also going to do 23 to 37. That's a little bit more involved, the 23 to 37. All right, so that is your assignment. Remember, I added 8 to 12. Don't forget that. Okay, so 8 to 12. Because remember on that last lesson, I was going to give you 1 to 12. All right, so that just fits that in there. All right, so 8 to 12, 23 to 37. That's your homework, and that is due tomorrow. We good? When do we get out of here? Pretty soon? 38. Yeah, we got like 2 minutes. All right, I'll actually let you talk for 2 minutes.